Anja.
Okay, so thanks everyone for joining this panel. We'll be discussing smaller footprints and how we can reduce our energy use. We are missing one panelist that will try to sneak in, and hopefully you won't be disturbed by that. But before we kick off the panel, I just want to make a brief introduction of the panelists, and then we'll start with some brief discussion on the panel, but then we also want to engage with you as the audience. We have both an online audience as well as the crowd here in the room. So please feel free to come with your questions. So in terms of the panel, and now I'm not reading in order of seating, because we changed that a bit, but we have Jan-Erik Sundgren, who's the Senior Advisor to the CEO at Volvo Group, based in Gothenburg. We have David Alshalom from the Liu Family Professor of Spintronics and Quantum Information at the Institute of Molecular Engineering at the University of Chicago, and a well-known pioneer in this field. We have Annelie Hultén, the Mayor and Chairman of the City Executive in Gothenburg and a long champion of sustainable development in Gothenburg, where we are today. We have Johan Rockström, who's a professor in environmental sciences at Stockholm University and director of the Stockholm Resilience Center. And among other things, I know Johan from the work of the UN Sustainable Development Solutions Network, where both Johan and myself and Ericsson is participating. We have Pan Fredman, who's the Vice Chancellor of the University of Gothenburg, and she's also held several leading positions with the university. So we have quite an expert group. My name is Elaine Weidman. I'm the Head of Sustainability for Ericsson, based in Sweden. So I thought, listening to the whole morning discussion, it was very interesting. We heard so much about increasing energy consumption and that being exacerbated by population growth and economic development in general. We heard quite a lot about global warming and greenhouse gases and really what's going on there. I thought it was very open and frank discussion, some of the comments made by Stephen Chu and others on that area. And we also talked about limited availability of resources, energy in the future. And on the other hand, our CEO, one of his themes was really looking at the vision and the need for transformative solutions for the future going forward. It doesn't matter if it's technology or if it's, could be any type of field really, but really the need for transformation. So I wanted to start with a general question to the panel and really ask, given the magnitude of the problem, is it enough really to just think about smaller footprints? Or do we need to do things more fundamentally different? So I thought I would just kick us off with that question and really look to you to see if anyone is burning for that. Maybe David, we had a brief conversation in the coffee area earlier, so.
And we can even discuss some of it.
Yeah.
Well, I mean, it's such a complex problem, and I think probably everyone here has a different perspective. But in the spirit of the Nobel Week dialogue, I do think it's important to think about how science can also help address some technological challenges to energy consumption and smaller footprints. Mm-hmm. And it's a little sobering if you look at things like electronics waste and industrial waste. At least in the United States alone, it's nicely reported that there are on the order of 400,000 cell phones, for example, being pushed away every day. And well over 100,000 computers every day are being disposed of. And you think about what's driving all of this. And as an industry, we've become fantastically efficient at making tiny footprints in electronics, based on charges. And companies like Intel make about 5 billion transistors a second. It's an extraordinary machine producing technology, but it's hard to see how that's going to continue. So I think when we think about how do we use energy, we heard this morning about batteries and storage and how we can really think about this as a critical resource. I think it's important to think about even looking back at electronics and taking a step backwards and think about, can new scientific discoveries play a role? Mm-hmm. And that's an area where I think developments like David Gross mentioned this morning in his presentation, how quantum physics can begin to play a role now even in technology, even building quantum electronics to completely change the way we think about information. So I think there are lots of directions to pursue.
Please.
Yeah, I think talking about small footprints, I think that we need the small footprints as well as the bigger steps. In my point of view, and it was raised, I think, during the panel discussion also, that how important it is to have education. I mean, we have people all around the world who are the accessors and the users, and small footprints could be the education of people around the world, seeing and knowing and facing the problems for the future. And with those small steps, I think we can do a lot. But without education, I don't think that we will have the biggest steps either.
Okay. And I know both Jan-Erik and Johan had a comment. So.
Well, it depends on what you mean by smaller footprint. If smaller footprint is translated to reduce environmental impacts, if footprint is translated to sort of say what has happened at the individual level, then it certainly is not sufficient. It has to be combined very clearly with a major transformation of societies, nations, and the world as a whole. I mean, I think what is so healthy with the discussion we're having here today is that we meet at a time where the science is totally unequivocal. All the cards are on the table. We need to decarbonize the world by mid-century. That's the biggest challenge humanity has ever faced, and it's not an incremental journey. It's a systematic, fundamental transition to a completely new logic of how we build wealth. And the beauty is that we're starting to tell this story in a completely new way. Up until recently, it was the story about burden sharing, contraction, convergence, difficult, back to the caves. Everyone was kind of fighting in their in the ditches. And now it's a story about opportunity, about innovation, about investment, about a cleaner, more democratic, more attractive, smarter, more efficient future. And I think that's what Hans Westerberg really was kind of manifesting. And I think that is starting to prove itself also on energy technologies. And so the question is not, do we have a problem? The question is not, is this a transformative journey? The question is, how do we now move? And I think, Jan-Erik, I've been so inspired by the way you've expressed it in the transport sector, so shoot.
Okay, no, I also don't think that this is the sort of getting the energy footprint smaller is the only solution. There is numerous ways that you have to take. But no matter what kind of energy source we use, we should, of course, use as little of it as possible. And that's true for every type of material that we have. We have raw materials that are scarce. We should use as little of it as possible. And from a business perspective, then there are lot of opportunities that you can take where you sort of advance your business at the same time as you reduce your own energy footprint and as you help to reduce the footprint of a larger society than sort of your own company. So I think there is a lot of opportunity, and I agree completely with Pam. Awareness raising is important, and there could be no better way of doing that than doing that through education. But then we really need to focus on this issue. And I think there is a lot of things to be done in terms of increasing the awareness. And starting with the young is never wrong.
But I think that you made, in addition to the point on education, you made a really fundamental point there about the cooperation that's needed now between companies, academia, and governments and so on, and to get the systemic change and the big shift that you're talking about. I mean, it's not going to be any one actor on its own. No. I know the mayor has a comment. I just want to acknowledge that and introduce very quickly Samida Silvera, who's a professor in energy systems and planning at KTH Royal Institute of Technology. So thank you for joining us.
Thank you sorry for being late. I was chairing another panel.
No problem. So please.
I think one important aspect this morning was actually the 1.4 billion people who actually don't have a footprint at all, nearly. So this is not the question just how we in the rich world is going to solve the problem. This is a question, how do we globally also do it in a way which at least can be spelled with some kind of equal measures. Because some people walk in very small shoes.
And how to decouple the footprint from the economic growth that the developing world so badly needs. So I think catching you up here. We're just having a quick comment.
I'm trying.
On if smaller footprints are really enough, or if we need more transformative or systemic shifts. If you had a comment on that.
I would like to take, I hope I'm not repeating what has been said before I arrived, but I think that is important to think the footprint in the complexity that it actually implies. I think the concept of footprint has been very useful for communicating the limits of resources to the people, and that has been very effective in this regard. But I think we should always remember the complexity that is embedded in it, because otherwise it has a very linear approach. And we cannot talk about the energy footprint only by itself. I think the integration often, let me give an example. I think it will be easier to understand what I mean. If you consider, we have the debate against fuel, gas versus food, for example, and they are always put in contrast. And while there may be also some challenges related to the competition for land and water, there is also a lot of synergy of potential. So wherever you have agriculture, you will have biomass for energy. And that, they go hand in hand. It's not either or, it's both. It's fiber, it's food, it's fuel at the same time. And then to understand how you actually optimize the sharing of these parts in the total. So that footprint measure is complex, is not linear. It's not about how much land you have to distribute either for food or for fuel, but is rather how we actually get an exponential effect of the way we are utilizing the resources that we have.
Did you have a comment?
That's a comment to what you're saying. I think it's very important that you see the different perspectives. And in addition to that, coming back to the education, I think it's important that we involve the knowledge from social sciences, from economic sciences, and so on, because there is not one or the other. And to deal with that, I think that the knowledge has to be shared between different disciplines, as well as it has to be shared between the society and the industry and the academia for the future. And the respect for different knowledge to be part of the energy future is important.
The preferences can be different too, isn't it?
Absolutely.
And Johan, I know that's something you have been working a lot with. I mean, all of these different areas, but fundamentally, I mean, economic growth and sustainability. Is this a contradiction in terms? I mean, can you have both or not?
Well, it's often, I would argue, wrongly been portrayed as a contradiction. And there's no doubt that we need to, that we can prove and that we need to pursue a path that makes these two synergistic. There is, in fact, just one future for humanity, which is sustainable development and therefore also sustainable growth, because a large majority on this planet needs more growth, not less growth. There is an argument to be made or a question to be raised whether or not we in the rich developed nations in the world actually benefit from more conventional growth. I mean, there's a lot of statistics to show that once you go beyond above something like $25,000 per capita per year in GDP income, net GDP income equivalent, we don't get happier. In fact, it gets very noisy. So of course there is, and same for energy. It's not as if you get just better and better lifestyles once you've crossed the threshold. So there is an argument to be made there that Tim Jackson does wonderfully, prosperity without growth in the richer nations, but that we need growth is no doubt, and energy drives growth. There's no doubt, but I think there's a very strong argument now that this has to occur within a safe operating space on Earth. It has to be simply made in a way that does not jeopardize the stability of our freshwater systems, our quality of our air, our ecosystems. And up until recently, we could actually do it unsustainably. We could use the atmosphere as this huge dumping site because the atmosphere was not sending invoices back to the economy. It's now doing so. We're starting to see the invoices coming back. And this is painful, but it's also a reminder that this is the last moment, so to say, to start veering into a new logic for growth, not, so to say, debunking growth necessarily.
And maybe as we're here in Gothenburg, I think it would be interesting to hear, we heard from the minister this morning about somehow Sweden has managed to get this at least partially right or is on the right track, combining both the economic growth with the decrease in CO2 emissions. And I know you have been very passionate about sustainable development in Gothenburg. Could you maybe share a little bit how you see it from your city, which we also heard is really the epicenter of energy consumption and CO2 emissions?
I think you would lie if you say that you couldn't find conflicts in this area. And we quite often do as well. Can you have a city producing cars and buses which are polluting and at the same time try to be sustainable? And I'm quite convinced that you can, absolutely. But you have to have the discussion all the time. And I think the mixture we have in Gothenburg for the moment, where you both have an industry which is interested in development, but also having the big universities, that creates some kind of a discussion and also an active area for going a bit further to both part, and also the local society to go a little bit further than before. Otherwise you can do the same thing once again, the same car once again, the same bus once again, but we don't do that. And we're trying to get a little bit better to change, and also to change the systems. But I'm absolutely at the same side as Pam is when it comes. You don't need just the techniques. You need the social behaviors, you need the political science, you need all other areas as well. Otherwise you can't change the society or go in another direction.
In buses and trucks and cars, I mean, that must be the perfect segue to you, Jan-Erik.
Thank you very much. Yeah, we are certainly part of the industry that pollutes the world, but we are also committed to make a change. And I mean, as been mentioned now several times, there are a number of routes going down that you can take going forward in terms of reducing energy efficiency or increasing energy efficiency. You have the science and technology route, which needs cooperation among the different stakeholders, among different disciplines. You have the policy, incentive or regulation route, and then you have the behavioral issues. And let me give you one example on the behavioral part. In the world, we consume on an annual basis 30 billion barrels of oil. And for those, one barrel is 159 liters, so you have to multiply, but barrels makes figures more round. Out of that, 70% is consumed by the transport sector. So that amounts to about 21, 22 billion barrels of oil. If you then say that, well, 60% of the transport is basically passenger car transport that we all can influence. Everyone that owns a car could influence that. So then you get down 60 out of 21 is 12 or 13 billion. If you have those 13 billion barrels of oil and say that, well, can I change my driving behavior such that I can reduce the fuel consumption by 5%? 5% only, and I think that is doable. I'm pretty sure that most of us that drives cars can do better than 5%. But if I take 5%, then we end up in 600-something million barrels of oil on an annual basis. In Sweden, in totally, we consume about 60 million barrels of oil for transport. So 600 million of barrels is a fair amount of energy savings. It's a fair amount of oil that we save on an annual basis by just reducing the fuel consumption, by driving in a more careful way. The question is, why don't we do that? And I guess there you have the energy efficiency gap, that you have a theoretical limit and then you have the practical limit. And again, I think education, awareness, and we need to really look at what we use energy for and not just see it as a commodity.
Could it be that too many men driving cars as well?
Yeah. You are probably right. You are probably right. But I think we are driving perhaps the wrong cars as well. I changed my behavior quite dramatically when I had the opportunity for more than a year to drive a pure electrical car. And then you say, well, that it doesn't emit any, it doesn't consume any oil at all. But I changed my behavior because I could see instantaneously how much energy that I use. Because it's very easy to measure amperes and volts. And so I changed my behavior. I can probably do better, but I think all of you can go out and reduce your energy consumption.
And it's unrealistic maybe to think that we won't use transportation. Of course we will need transportation, and then it's a way of more a question of optimizing and having the most efficient way.
Of course we need to have transportation. It would be sort of foolish and naive to don't think that we need that. Then of course we have a part of the world where we have heard today they don't have electricity, they don't have access to water, and they obviously cannot reduce their energy. That's obvious.
David.
But what they can do is leapfrog.
That's right.
No, I was just very pleased to hear that technology can change your behavior. That gives me optimism. I'm glad to hear that. And it's true, electric cars give you positive feedback, and there's a great psychological pleasure to know you're getting just a little bit more mileage per gallon. But you might also think about models where you don't need cars at all, which might be anathema to you, but I think it's something to think about.
Need buses.
Yeah.
That was an advert.
No, you'll be fine. You'll be fine. I wouldn't lose sleep over this. But you could think also broadly. I think technology is also important to think about. Suppose with your vehicles you could reduce the weight by 50%, which is definitely possible with new material science. That would have a dramatic impact on fuel utilization, and I think it'd be far more than saving 5%. It would be a huge impact. So I really like what you were saying about education, because I think, in my view, you have to think about energy as a resource that needs a very broad set of skills to accomplish these goals. And I don't think there's one answer. But I think the way students think about it, to me, is actually, I'm very optimistic about it, because I think students do have a very broad approach. And I think they're very comfortable with thinking about behavioral changes, about technology, about policy. I think students are very interested in getting involved in government policy. It's frustrating. But
also the new generation, they're not going to drive or do the things that we did in the same way. They'll be using Uber, they'll be taking services instead of physical products, and I think there's a huge opportunity just there. I know you had another comment, and then I will open it up to the floor and start to take some questions, and if not, then I'll continue asking questions, but please, Pam.
I would like to give another comment, and that's back to technology, but because at the same time we have to reduce the uses of energy. We have a large part of the world who needs energy, they don't have that. And I think that one issue which was raised this morning is actually a single thing, and that is that you can't provide vaccines to a large population who needs vaccines for children and for the population, because you don't have a refrigerator, because you have to go. One small footprint would just be economic devices which can save the vaccines. That could help a lot and a huge amount of people around the world.
Absolutely. Even issues such as pure water as a resource, right? I mean, simple solutions that would allow, smart straws, which are being delivered now, as you probably know, right, to purify water during consumption, have an enormous impact, ultimately on energy utilization as well.
Okay, Samida, you had a...
Yeah, I just wanted to make a comment about the different levels of decision-making and the implications of that. One is this, about the possibility that some technologies that maybe not so new, but that are now being disseminated, offer to for example, provide vaccines and electricity in remote areas and so forth, but also in a completely different scale, the importance of making changes at the system level, which, for example, a city can actually accomplish, and without the orchestration of the decision makers at the city level, for example, where a lot of the energy is being used, but also a lot of value is being produced, you cannot actually channel the actions of the different actors. And we often talk about the users or the consumers sending messages to producers and so forth, but we really need to make it easy for the consumers to make the right decisions. So we need to actually put pressure on the actors that can innovate at the system level or orchestrate change at the system level, so that when the user wants to make a decision that is a conscious decision, it's easy for them. I used to work many years ago in the Swedish Energy Agency, and we discussed why are not people using more pellets in their homes. And then we had an internal evaluation of that, and it turned out that if you wanted to actually have a pellets to heat your home, you had to make 36 calls. So it was no wonder. So even if you were very interested, you had to make so many calls to actually come to that. So probably you would have given up. You have heard that it is a good option, but you would have given up already after 2-3 calls. So we really have to put in place also indicators that make it easy for the users to make those decisions and to follow up what is actually being accomplished.
Okay, so let's open it up to some questions. Just ask you to keep your question pretty specific, and if you have a specific panelist you want to ask, then feel free. If not, then we'll take the question and see who wants to volunteer for the question. So, any questions from the audience over there?
Yes. What about city planning? I mean, if you have to travel to get to work, or if you have to travel, I mean, the cities in the 50s, 60s, 70s, they were built around that you should own a car and you should drive from work to home and home to work. And what about, so to say, making larger cities smaller?
And even using the parts of cities that are abandoned and no longer used, actually. So I guess that's a perfect setup for a city mayor.
I think that the discussion already about transportation shows that we have sometimes a very narrow view of transportation is for us car. But if you are in a city, and especially when the city are growing, you have to talk about mobility instead. I think so. That you actually change mode of transportation during the day. That is not just, you don't need to just have the car. You can bike, you can go by the tram, bus, whatever. City planning is crucial. The problem is also, or the challenge, is if you have the city planning from the 50s and 60s, which we have in many Swedish cities, then it's a challenge to change it. And in Gothenburg, I think everybody who have been in Gothenburg this autumn know that we have had a huge discussion about congestion charges. Are we going to change or are we not going to change? I'm completely convinced we have to change. Especially, and not just for the city. I think even we can talk about the region, because we're not so many people in a quite huge area. So if we want to squeeze a little bit closer to each other, we need a proper transportation system, which is from the mobility view, not just one transport.
And Jan-Erik, you had a comment, and then we have another question coming.
No, I mean, it's quite clearly that urban areas are extremely important and for sort of devising and creating new transport system. And I think there is no single type of solution. You need a multitude of solutions. And I think we have a good cooperation here in Gothenburg. We are trying now to not only use trams, but also use very energy efficient buses like plug-in hybrid buses, which has an energy consumption or fuel reduction that is 80% compared to a normal diesel bus. In view of that, we have taken a decision not to sell city buses that is propelled only by diesel from 1st of January 2014. They will all be hybrid buses, and how to create system for that to be effective. We will now, in the project we have in Gothenburg, have indoor places where you can embark and disembark the bus. So I think we need new transportation systems. Still, there are some parts in this country and in the world that still will need cars, of course.
Very good question. Thank you. One coming over here.
Axel,
and maybe say who you are.
I'm Axel Wemblad. I'm chairman of the Swedish WWF, but I also have a background in construction. I just came back from 4 weeks in the Philippines, and being interested in construction and energy efficiency, I've been working with this in Sweden, in our part of the world, but looking in those countries in the tropics, when you build new buildings, there's no trace of any energy efficiency thinking as I could see. And that's where you have the most of the expansion. You're building for maybe 50 or maybe 100 years in the future, and I don't see a trace there. I don't have the solution, but I think it's extremely important that we are trying to develop these kind of technologies, these ways of thinking in those countries as well, because otherwise we are not on the path of solving. We are doing a lot in Sweden. I think we should do much, much more, but in those countries like Greater Manila, I couldn't see a trace of energy efficiency at all in new buildings.
Okay, so I think there's a couple, I mean, you started, Johan, on the systematic, fundamental change, and then we have transportation, we have buildings, we have energy systems. So it is, you know, this whole part, all the major sectors of society, I think that we need to really start to do things differently. I mean, what do you say to the comment here?
I was earlier about to be very critical about Sweden, but now you open to be a bit more positive, so then I can throw out both and it balances. Because I think Sweden is risking to lag behind on the whole area of city planning with regards to transport systems. I think we need to soon go to Costa Rica and learn how to plan cities in order to have really good public transport systems and bicycle systems. And, you know, I just... Gothenburg I won't talk about, but Stockholm, certainly I look forward when Sveavägen is you know, closed down. It's just cycle lanes going right through because it will be so effective. This we're lacking in Sweden, but where we are really good is what Axel is pointing out, that, you know, if you talk to the construction companies in Sweden like Vasakronan, JM, etc., they are well ahead of the legislation even. They build houses now which are half the energy requirements, even compared to Swedish legislation, which is best in the world. So, I mean, we have a know-how here, and 60% of the cities are not built yet up until 2030. So, you know, the momentum on city development in the world is just enormous, and you're absolutely right. We're not using that opportunity, which is not only about energy efficiency in buildings, it's about the entire physical landscape for your buses, not least.
Can I make one more comment on transportation? Because we often come into discussion if it's public transportation or if it should be buses, trams, subways, or what have you, or cars. But we basically all the time forget that we have to have goods going into the cities, we have to have garbage going out of the cities, and we also need to rethink how goods transportation occurs in urban areas. And I think there we have a great potential in Sweden to advance that area, because it doesn't come, your bottle of milk doesn't come to your local ICA store by train. It doesn't come there by quantum mechanical tunneling either. It really comes there by a truck, but it doesn't necessarily have to look the same as it does right now.
Urban agriculture.
Yeah, right. But maybe.
But I think it's interesting. Of course, what you're saying is true. And then we were just, from Ericsson's side, involved in a really big cities event about 2 weeks ago, and discussing many challenges around urbanization and technological advancements and so on. And I think it's so interesting now with like Minecraft, you know, and the partnership with UN Habitat, looking, I mean, back again on education, looking and getting the youth engaged in, actually to, the UN Habitat, I just met them 2 weeks ago, they have a community of 25,000 youth around the world engaged collaboratively on discussing how, you know, to solve some of the city challenges. So I think, as you said, we wouldn't hardly know what Costa Rica did 20 years ago, but today we are so much more able to share and exchange ideas and everything and get the information. And it's the same if you look at mobile banking or healthcare. Sometimes the innovations are coming out of Kenya or India or other parts of the world, and now we're at a point in the society where we can actually start to gather that and learn. I know there was another question here that I can take in.
Isadora Wronski from Greenpeace. I have a question regarding your view on the need of goals, specifically for 2030, because there's a huge discussion going on in the EU right now, and the targets will be set in March, even though there's a longer process. But how much of a driving force is it for all the rest of development, in your view?
Any comment on goals, European or Swedish or otherwise?
Yeah, well, from my perspective, goals are absolutely necessary. I think to unlock the potential of what we've been talking about, and particularly your example, Jan-Erik, about changing behavior on everything from driving to building standards, requires political leadership and very, very ambitious goals. So setting a 60% reduction goal for 2030 within the European Union is not only necessary from a scientific perspective, it's probably also a very important component of unlocking the kind of technological and behavioral breakthroughs that are required. The goal alone will, of course, not be enough. You have to couple it then with very, very clear political measures, like a carbon price, like taxes. So you have to kind of work at all with your whole portfolio.
Pam and then Anneli both had comments.
We're talking about small footprints here today, and I think that what you were asking for were the big goals, for the European society and so on. I think that the goals for the regional, the cities, and also even smaller, because they are more easy to reach. And I think that we have too many goals today. We never reach them. And finally, there is no trust in that. So small footprints, reaching goals within the city, within your own company, or within the universities we have, I think that could help to reach goals.
Small goals instead of big goals? Or
both, of course. Yeah. But I think that there is a disappointment if you put up goals and people see that you never reach them anyhow. And then small goals could be easier to reach.
So Anneli and Jan-Erik, and then I'm going to check in with the online questions. Please.
Especially when it comes to CO2, you have to have goals on each level, on the European, national, and of course on local level as well. And I think if you should be a bit critical against Swedish politics, is that we actually say we have to wait and see what EU come up with. We should be the driving force. We should say that we are demanding this of the European Union, not just sit back and wait.
I think big goals are important. And I'll give you one example of where Sweden has really succeeded. When Sweden took on the goal, Vision Zero, to have 0 fatalities on the roads, then we departed the increasing traffic with the increasing accidents. So the scissor was taken wide open. And we have now the lowest fatalities on the roads, except I think Malta is lower per inhabitant. But still, that has really, really helped to shape the sort of road safety in Sweden. And I think the goal that we have currently by having a fossil-free vehicle fleet by 2030, even though I can have my doubts if we're going to reach it. I can have my doubts if we're going to reach Vision Zero also, but it has been driving a good behavior.
And a good vision.
And a good vision.
Can we have a quick update from online if there's any questions?
Yeah, so this is a question from the online audience, and it's basically a question for all of you.
Okay.
And it's, what can your organization do, or what are you already doing to make smaller footprints? Concrete examples.
We heard a couple from Volvo. Did you want to come in there?
Well, I'd like to comment on, I work at the Rio Institute of Technology, and one of the things that we do is to actually enhance the dimension of sustainability in engineering education. And I find that engineers are excellent for solving problems. But of course, if you define the problem without taking into account the constraints, then you will have the wrong solution. And I think in energy, it's pretty much like that. We actually have been able to find the solutions for providing energy deployment in different parts of the world. And we have had a whole industrialization on that. But now we have to rearrange this question. And by introducing these dimensions in engineering education, then engineers are aware that it's not just about the energy conversion, it's about actually taking into account also resource utilization. It's about the constraints, the impacts that we generate. And in energy, obviously, we have had some of the strongest impacts on nature of energy deployment and use. So we need to change that question and to be able to provide the solutions at both at the unit level, but also obviously at the system level to have the impact that we want to have.
David?
Yeah, I mean, to address the question about how your organization is dealing with some of this, I mean, and to follow on what you were saying, I mean, I've recently moved from California to Chicago, which is challenging in its own way. But one of the reasons I moved there is that University of Chicago, which is a large U.S. university, is undergoing an enormous U.S. initiative now to change the way graduate students are trained in applied sciences, running a little bit more like a medical school than an engineering program. And part of the theme is to integrate students in the arts, the sciences, for societal problems. And they've picked 3 or 4, at least in the first phase, major areas. One is which is energy, another is water, and different topics which are viewed as global issues too. And our view is that it's very important to train students to think very differently, collaborate across the disciplines very differently, and invest in that. So that's one way to address the people behind your computer who've asked this. The other issue, which I think is important, pertains to industry. And there, at least our perspective is it's very important to develop very strong interactions collaboratively with industries and universities from the very beginning, at all levels, for short-term solutions and for 20-year solutions. And I think students also find this extremely attractive, and at least in the US, it's incredibly productive into the business sector. And I want to make one quick comment about, as a non-Swede, about goals, to address the question that was raised here. I think personally it's very important to have big goals. And I don't think we should let the political system limit our goals. I think if that was the case, we would never send people to the moon. There's no obvious reason to do that. But the economic impact was fantastic, right? Inarguably fantastic. Nobody would argue with what came out of that mission. And I think it's okay to fail. Maybe that's peculiarly American, but failure is not so bad if you learn something from it. So to the students in the room, I would say, don't worry so much about failing. You know, listen to what your parents say, but just a little bit. And take risks and be bold, and you know, you'll be successful.
I think one of the things it sounds very interesting, the program you described at the university, because I think even from the private sector, from Ericsson, when we've been looking at the urbanization challenges, we're thinking, you know, historically, we have been the ICT sector, and then you have had the transport sector, and then you have had the energy sector, and everybody is in their own vertical or their own silo. And I think now it's coming to the point where we have to think more cross-sector. And it's funny, because you describe the same dilemma, but from the students in the university, and we're looking at that from the company's point of view. We have been cooperating with Volvo on connected vehicles. We have been cooperating with different energy companies, looking how do you get the ICT together with that sector and try to find more of the transformation. So it's very interesting. Thank you.
It's wonderful to hear, and I hope really that the industry and other part of the official sector also recognize those students who are coming with this broad knowledge, and because I'm not sure that that's the case today. We are very, very narrow-minded when it comes to education, and if everyone really recognize the value of having different disciplines and also having different values from the educational programs.
Well, you know, it's interesting. When I was in California, I ran something called the California Nanosystems Institute, which had many, many, many companies involved, from startups to Intel and HP. And we would often get complaints from the companies, quite reasonable complaints, saying, you know what, you're not doing a great job training students because we need to hire students, and we're not hiring them from you because they're not trained quite the right way. And it was fascinating because these were an enormous range of companies. So I agree with you, but I'm optimistic. I think that companies will embrace these students because we see it. They evaporate quickly. So that's a good thing.
More
so
comments or questions from the there's a couple over in the back here. I don't know who has the mic.
Yeah, I have another question.
Just maybe introduce yourself.
My name is Per, and I'm just a random citizen.
Okay. Great.
But one thing about cars, if we return to cars,
transports.
having a large car or a sports car or anything is kind of a social marker. and it's cool to have a car, and it's very uncool to take the bus. If I drive around in a small bicycle or velomobile, for instance, with an electric car, I will be considered strange, and people will perhaps laugh. Why do you drive this kind of strange thing? The problem is how to make sustainable things cheap, sustainable things cool.
And how to incentivize them.
I think electrical cars are pretty darn cool.
I agree. Then it's very expensive.
The coolest car in California is a Tesla. But
Too
there are also
expensive,
cheap.
he's saying.
Yeah, I agree with you.
If I drive a very small velomobile with an electric motor, I'm not cool at all.
but the coolest thing in Beijing is probably a two-wheeler with an electrical.
But the coolest thing in Gothenburg for the moment, especially this time of year, is a bicycle. That's for sure.
Or a plug-in hybrid
and
bus.
that works. That works. So of course, we had a discussion during lunch because all these seminars and the discussion this morning creates lots of thoughts. What are we doing? How should we do it? And of course, there is also some kind of, as you say, we have this is social status to have certain things, and maybe we should start to value things differently. What is worth something? Is it time, or is it that you spend time with your friends, or is it being out in the nature, or whatever? Has it always to be products or some kind of lifestyle symbols? I think we have to change a bit to be there.
There was one more question in the back there. If you could take that.
Thanks. Hi, I'm John Timmer. I write for an online news site called Ars Technica. One of the things that came up in the morning sessions was that the IEA has this list of efficient technologies that could make an incredible dent in our carbon footprint and would return a profit in a very short time window, yet they're not being adopted. How do we get businesses to actually help themselves by adopting efficient technologies more quickly?
Johan?
Yeah, well, there are probably many answers to that, but I think it's good to link an answer to your question to the previous question about, it shouldn't only be cool, but it should be cheap. I think the biggest mistake of all is that the economic rationale today is that you should not only be enlightened, you should be prepared to pay more to be sustainable. In fact, the future must be that even an indifferent person should automatically become sustainable in all choices because it's much cheaper. Therefore, you have to penalize doing wrong and allow doing right to be much cheaper. In fact, the reason why we can consume cheaper tomatoes flown in from Spain or meat that has flown around the world is that the planet subsidizes it. We're not paying the full price. So just getting the price mechanism right, I think, is one part of the solution, both for making cycling cool and to make the big transitions in terms of investments occur. To get, every industry today more or less acts rational from the perspective of the playing field that they see, the horizon they see. And the horizon they see is zero cost of emitting carbon dioxide, so therefore it's rational to continue as today. If you would raise the cost, you would change that behavior very, very rapidly, also in investments. I mean, just look at coal. Again, a plateau price of 30 euros per ton of carbon dioxide in Europe would probably create a race away from coal. Now we're seeing a movement back to coal because of the collapse of the trading system.
Yes, thank you. It's getting really interesting and the dialogue's going, but we're completely out of time. Yeah. So we were given till 1:45, so I'm sorry we have to wrap up. So I would like to thank each of you for your different perspectives on smaller footprints, systemic change, many different contributions. So please join me to thank the panel for their contribution. Thank you.
No? Ah, that's better. Okay, so good afternoon, ladies and gentlemen, and welcome to this session on nuclear power to those in the room and also to our viewers who are seeing this on a webcast. Time's very short indeed. I've been told we should finish by 4:30, so I'm going to have to ask everybody to be extremely brief because we want to have time for questions. I think everybody on the panel has spoken before, so I'm not going to introduce them, with one exception, which is Elizabeth Rachleff, who is a professor at the Royal Institute of Technology and a member of the Physics Class and Energy Committee of the Royal Swedish Academy, and is co-chair of the European Academy's Science Advisory Council study on breakthroughs in sustainable energy supply and consumption by 2050.
Okay, thank you.
So I think we might start straight away, and I'd like to start by asking Steve Chu to give us very briefly his perspective on the outlook for nuclear power in the world or the US, whichever.
Well, it's very personalized country to country. In the United States, it's very personalized state to state. There are 4 issues.
Is that switched on?
Yes. Okay. There are 4 issues. One is safety, especially after Fukushima. There's safety concern. There is a proliferation concern. I think some countries who want nuclear may want it to gain access to some of this technology and do a bit of bomb material building on the side, or dirty bomb collection material building on the side. So that's another issue. There's the spent fuel / waste problem. In today's light water reactors, we use about 1% of the energy content of the fuel before it's deemed waste. If you begin to close the fuel cycle, you can get it up to 30, 40, 50%. So that means 30, 40, 50 times more energy per unit of material. Also, if you do it right with fast neutrons, optimized for burn down, you can reduce the storage time by several orders of magnitude. It turns it from a 500,000-year problem into a few hundred to 1,000-year problem. So that is very different, but it requires technologies we have not commercialized successfully yet. Finally, there's the economic cost. The capex of conventional nuclear is about $8 billion per gigawatt, or 1.5 gigawatts, maybe $10 billion, so there's a little economy of scale. Most utility companies, that's a large fraction of their assets. That could be 1/2, 1/3, 1/4 of their total assets. If the reactor is built with a 2-year delay, 4-year delay, and they're not compensated, that's a financial hole they can't get out of. So there are many, many issues. And then finally, I should say that I don't think we will need fission by the end of this century for sure. We're going to transition to other things. Renewables, maybe we can get fusion to work, maybe not, but renewable storage, transmission. So it's not, it's, hopefully maybe not in the last quarter of this century, we may not need it. Do I think we need it now, and do I think we should close down nuclear reactors that have 20-year lifetime still in them? No, I think I'll keep them operating safely. So that's quickly.
Thank you very much, Steve. Now, Robert, I know you've thought about public perception of nuclear.
Yes.
So,
well, what's of course interesting with the whole nuclear issue, apart from the kind of, I would say, almost kind of the rationale you just sketched, the 4 elements that in the public perception there are various elements that are kind of competing. Safety is one of it, but certainly it's often also placed in the context of energy dependence or independence. The climate change way of looking at nuclear, and then definitely also the cost. And one thing which I find kind of interesting, and it's kind of brought also into light with the Fukushima event, is that you saw countries reacting very differently, and that not all of these reactions are entirely rational, but even you see, for instance, sometimes in certain countries a strong support for nuclear. I think Sweden is a case where it wouldn't be energy dependent so much because there are some other renewables, while countries like Germany, which in some sense have less opportunities, they strongly are against it. And so I think it's very important that if we have a kind of healthy debate about nuclear option, that at least there is a lot of discussion with the public to at least bring the scientific community and the public on the same page in terms of what the arguments that you should address and what kind of conclusions you should draw about. And of course, we have seen that that there's a difference here between kind of risk assessments and actual events happening. I think the public perception really is very much steered by 1 or 2 or 3 events. Well, I think there's a much deeper discussion there to be held about what exactly is the risk environment and what are the kind of regulatory framework do we need, what is the role of government and all of that. And often this, I notice, is kind of reduced to kind of a caricature in the opinion pages of the newspaper, so to say.
Thank you very much, Elizabeth. I know you have views about the future pathways we should be pursuing.
Yeah, so I think that nuclear power is not cut in stone. It's a research area, research and development. And there are many things that we can make much better. We can have better fission reactors which are not cooled by water. We can take care of the waste by using it again, for example, in transmutation, like Carlo suggested 20 years ago, and it's still not commercialized, but we have a lot of energetic waste lying there that we can use. We don't need to take up anything new if we build reactors which can actually use this waste. We can have thorium reactors. We know we have lots of thorium in the world, so we can do a lot of things with the nuclear fission reactors as we have them now. We also, like Stephen said, and like my heart is on the fusion, which Carlos says is terrible, I still think that it will be quite nice, and it will be a renewable also. We can have a combination of fusion and fission, which is also a possibility. So there are many research areas where we can go within the nuclear physics. And it's something that we need to tell, that we are in the research area, and we are, for example, the new fusion experiment that's being built now, ITER, is still an experiment. We haven't built a reactor yet, so we are still in the research. It's not ready yet, but we have many reactors, and I definitely think we should use them. But what we have to do is to get the information properly, because saying, for example, that there will be people saying in Fukushima, 300,000 people died because of Fukushima. It wasn't because of the reactor that things happened there. It could very well be predicted that there would be an earthquake, and at such a large earthquake there will be a wave. So that was really nothing strange in the whole thing. The reactor had nothing to do with that. But the information has to come out in the proper way, and it's up to us to have a proper education.
Thank you. Carlo, you also have views on the way ahead, I know.
Well, I think I will continue a little bit of what Stephen Chu said about these 4 major questions which are there. I will add another one, which says that essentially after the Fukushima result, after the Fukushima situation, it seems to me that a country like Japan, which was one of the most advanced countries with incredible technology, gets itself into such a mess as what happened at Fukushima times, is an indication that the situation on nuclear power has to be deeply, profoundly revised in order to continue as such. To continue means after finishing up the regular, natural, ordinary closing or whatever activities. No hurry, you don't have to switch everything off tomorrow. But when the new reactor will be needed, they have to be of different nature. Now, they have to be essentially the probabilistic approaches behind all this. Probability means, for instance, if a pump doesn't work, as it happened in Fukushima, you make a second pump, which will replace the first one. If the second one doesn't work, you put a third one. So you reduce the probability to a value which is so low that it seems to be 0. But it's not 0, because the product of a very large accident times a very small probability can give you a signal which is finite anyway, which is not acceptable for many people. So you have to go deterministic. You must be sure that things are done according to such a way that physics law would not allow you to do this. And there are ways of doing this. You have to replace various kinds of things. Now, second problem is there's no more energy from nuclear power than there is energy from fossils. The amount of use it this way. It is another point that Joe has mentioned, namely that today we are only using a very small fraction of the nuclear energy. For instance, you take 1 gigawatt electric for 1 year. In order to do it with coal, it takes 3 million tons of coal, which is a hell of a lot of coals, which make 10 million tons of CO2 in the air. So if you go nuclear, ordinary nuclear, is 200 tons of uranium that you need in order to get the same results. If you go with thorium, with a well-designed thorium machine, only 1 ton is necessary. Now, most of the thorium is not like the uranium in the sea is on the Earth, and there is a large amount of thorium. So thorium is really quite an interesting alternative, very similar to the alternative from fusion. So since my time is very short, let me mention about fusion. I am not convinced that the fusion chosen with the tritium is a step in the right direction. Because I believe that, first of all, fusion is inducing much higher energy neutrons and many more neutrons. There are 7 times more neutrons per given energy production with fusion than there are with fission. And fission produces 14 MeV neutrons, which are much harder to use than the 2 MeV neutrons, which are typically to fusion. So it's a step in the wrong direction. In my view, fusion has to be aneutronic. In my view, the ultimate form of fusion is a fusion in which you no longer have radioactivity, you no longer radioactive material, no beta, no alpha, only alpha. And there are examples of these things which are perfectly profitable, but they're not studied by anybody, which in my view is the correct direction. There is the example of lithium 7 plus proton, which goes to beryllium 8, which makes 2 alpha particles. This is still a little bit of radioactivity there, but the best solution is boron 11, for which you have plenty, plus proton, which you also plenty, give you 3 alpha particles. These 3 alpha particles produce electricity directly because the alpha particle have a couple of MeV of kinetic energy, which is slowed down electrostatically, and therefore you have a system which has absolutely no radiation at all. So it can be carried in a car or in an airplane, as you mentioned before, because there's no radioactivity at all. It can provide you with a very high efficiency and direct electricity production, as you do in the other system, with about 1.5 to 2 million volts, which is what is needed to produce 1 megawatt for 1 amp of current. So in my view, I think the fusion solution should have less heat exchangers, less gadgets, less materials, and they should concentrate themselves rather on the fundamental fusion. And there are many, many nuclear reactions which are possible with fusion. And if you have fusion, God damn it, you should have no fission fragment, no radioactivity at all. Now, this is essentially my point of view, on the point of view where things should be spent. So I am a little bit antagonistic with respect to the general point of view that you have mentioned.
I mean, Carlo, let me comment on that. I agree with you in principle, but the fusion you're against is incredibly difficult. What you're proposing is even harder.
You haven't tried. I'm sorry. How many hours of your time a day you spend on fusion?
At the moment, I'm not spending time.
So
she is. I was for many years. Anyway, let's go to questions now. Who would like to ask? Over here.
Excuse me. You should never say impossible.
No. I don't say it's impossible.
Can you hear me?
Yes.
Yeah, I'm Per. I'm just a random citizen. I have some questions about the thorium reaction. You have talked about it's more abundant, it uses all the energy, and then a couple of other questions. Does it really make less dangerous waste? Yes. Is it less weapon potential? And you don't have to have a pressurized vessel? And my last thing is, did the US make a thorium breeder reactor? But what I've been told is that they made a thorium breeder reactor, but they realized that it could not be used to make nuclear weapons. So therefore they stopped using this.
You want to?
Maybe if the question
is easy.
The question on thorium, I can try to answer. The first question is, you're saying to you, can you make a bomb with thorium? The answer is extremely difficult. extremely difficult because the uranium-233 is very heavily polluted with thallium-208, which is a very strong radioactive substance, and you produce a huge amount of radioactivity. The general of the military, which is in front of a thermonuclear bomb, will get a little dose in few minutes of radioactivity. That will not be something. Contact is fundamental for a bomb, and this is not there. Second question you said is about the time, the duration of this radioactivity. There are two elements in radioactivity. One is fission fragments. Fission fragments are dominated essentially by elements which have 30 years of lifetime. So as you correctly pointed out, Professor Schuh has correctly pointed out, in something like a few hundred years, the whole thing is decayed to a level which is essentially zilch. You can take it out. The second question are the long-lived material. The long-lived material in the case of thorium is uranium-233, which is a perfectly legitimate object, uranium-234, which in the old days uranium are becoming the seeds of the next process. So there is no waste of the actinides, because the actinides becomes the seed for the next activity. The only actinides which are not the seed are the plutonium, but there is only plutonium-238, which is there, the probability 1 part in 10 to the 8, because you have to have 7 neutrons to go from thorium to plutonium-238, and the whole situation is much worse even with 239, with americium, curium. There's nothing of that. So therefore, the materials in the thorium are dominated by the uranium material, which are the seeds of the next system. Now, those seeds are separated in a very simple way, because you know the fluorination is a mechanism which can be allowed in order to extract uranium from other materials just by evaporation. The hexyl fluoride is a gas, and therefore you take out of the gas the seeds, and you put the seeds in the next cycle, and all the rest is essentially dominated by waste, and the waste is mostly fission fragments. In a few years, go away.
Okay. Does anyone on the panel want to say anything about thorium?
We just want to make a kind of a correction in the question. The U.S. did not build a thorium reactor. We built a fast neutron reactor. China and India are both looking to building thorium reactors, but they haven't built it. As far as I know, they haven't built them because they both have a lot of thorium in their country. But it's again a research project.
I can add also thorium, since we are in Sweden, and I come from Norway. Norway has found a lot of thorium, so that they are also participating, and it has come so far that they are going to put thorium as fuel, test fuel, in their research reactor in Halden. So
thorium is extremely cheap fuel, $50.
Right. We're not disagreeing
okay.
with you.
More questions from the audience? I have one over here. Can we have a microphone?
Many questions.
Thank you. I'm Mohammad Moshir Rahman. I'm from Bangladesh. I have just one question, a very small question. How can nuclear power help in a safer ecosystem and reduction in carbon dioxide? That's all.
Simply because it doesn't make any. It's replacing coal. Did I not understand the question?
How can nuclear power help in a safer ecosystem? I mean, I want to mean actually we're using nuclear power for making different devastating weapons. So before this seminar, actually, we are discussing about how can we reduce the energy uses. So my question is related with this. How can we use this nuclear power just to for the safer ecosystem? How can we help? How can we use it? And for the reduction of the carbon dioxide. Yeah. Did you understand?
I'm not sure I understand the question, apart from the fact that you're not producing carbon dioxide, so you're using less fossil fuels. If the use of the power, it doesn't matter where it comes from, how you use it. Once you've generated electricity, how you use it is...
Actually, I asked a little indirectly. I want to ask you, is it possible to use the nuclear power in a safer way so that the whole planet will be safe in future? That's my question, actually.
Well, I think that's a question that people talked about at the beginning, that it's a problem, but there are safer ways of doing it, Carlo is saying anyway.
Let me start by first saying, statistically, if you look at how many deaths there are per terawatt hour of electricity generated, including Chernobyl, and making you know, Fukushima, there could be hundreds of cancers in the future. There's no direct deaths yet. 3 Mile Island, none even estimated. Chernobyl, several hundred. Okay, you know what the ratio is between that and coal? 6,000 to 1. 6,000 to 1, coal to nuclear, in terms of deaths. Right. And it's going to be much worse because the extreme air pollution of the small particulate matter, 2.5 micron, that is giving respiratory illnesses for young children. So the full impact of that is not even felt yet. Okay? So in terms of safety, there is no comparison.
Yep.
Excuse me.
I mean, air pollution is killing outdoor about 1.3 million people a year out of 60 million deaths. Typically 8 years loss of life. Indoor air pollution about 1.5 million. Those numbers are a nuclear war, not a nuclear accident. And if you ask direct deaths, those are indirect from air pollution. The most dangerous form of power, according to a Swiss study per kilowatt hour, is hydropower. It's breaking dams, drowning people, and accidents in construction of dams.
May I just add a little bit to what you say? First of all, let me give you 2 factors. Every second, 18 people die on Earth and 20 are born. The difference of 2 per second makes the population explosions, which is 80 million per year, 1 billion every decade. These are the numbers you're looking at. Compared to those numbers, obviously, what you're talking about is an absolutely negligible element, respect to 20 per second. However, you should not look at this as a number. You should ask yourself, what is the population thinking? When you go to Germany, I don't think there has been any single serious accident in Germany. But if you ask any German citizen, do you want nuclear? It says, no, nein, danke. This is a fact. So there are factors which have nothing to do with a simple risk analysis story, which has to do with the way in which your people, especially the voters, feel to decide on something. And this something has to be taken into account. Thanks God, this is not a question of death of life, but it's certainly a question of opinion. And the opinion making is fundamental when it takes to get somewhere with one solution rather than the other.
I think, sorry, Steve.
I also want to add, even with their existing fleet, what we learned in Fukushima, there are some lessons learned there. For example, those reactors were cut off from the water supply, they were cut off from the electricity supply. In California, we have nuclear reactors, and in a major earthquake, you can expect to be cut off from your electricity and your water. And so there's a big water reservoir sitting above in those reactors. So for the first day or two, you can cool those reactors. The first day or two are the most critical. Another lesson we learned in Fukushima is the operator training wasn't as deep as we thought it was. It turned out that, in the United States after 3 Mile Island, we do a lot of simulator training, but in addition to that, they have the authority to do things in that reactor. You can't radio to the head of TEPCO, the utility company, or the Japanese government to ask for permission to do something. You have to be reacting much more quickly. And in Japan, they did not have that. They would have to go up the chain, and then the higher up the chain you go, except in occasional circumstances, the least knowledgeable you become. And so imagine you're an airline pilot and United Airlines, and then your engine stalls at 40,000 feet. You do not want to be radioing the CEO of United Airlines to ask what to do. So similarly, in reactor training, the operators on site have to know what to do. They can be drilled on simulations out the wazoo, just as airline pilots have done. We learned a lot of things. One final, this is actually no expense. This is very low budget. Finally, what we learned is that there were appallingly few sensors in those reactors when they went way off normal. And so for the first month of Fukushima, I spent a lot of time. There was a little crew of working with me. We were trying to help the government. We didn't know what the pH was in the reactor pressure vessel. We didn't know what the hydrogen content was. We did lots of calculations, but there were only calculations. There was nothing that allowed us to get in and get a sample of what was going on. And you're pouring salt water in, you're evaporating the water, and it's getting more salty. We can only do a calculation. It's when the salt would precipitate so much you couldn't cool it anymore, and you'd get a melt through. you can redesign the reactors today to go and get a little biopsy, if you will. We crawled around a decommissioning reactor of the same design. You would have to bleed it out in a line, but you'd have to bleed for many, many hours in order to get a clean sample out of a thin line. Okay, so even things like that, sensors, the cooling pool, there was no sensor that tells you when the water, how deep the water was beyond the normal operating level. You can actually have hydraulic tube that goes down to the bottom. You know what the density of water is. You can bring it out. It doesn't even have to be electrical readout. There was none of that. There was no yardstick that tells you how deep the water was. So you can have a lot of very inexpensive, redundant measurements of once it goes off normal, so that we can, in other words, we're just doing calculations. And as an experimentalist, man, I felt really queasy about lots of calculations. I wanted real data. Is there really, one of the spent fuel pools, was there really water? And so the existing fleet can be made much safer, and the training can be made much better.
As a theorist, I feel even more queasy about calculations. Carlo, very briefly, because we have a lot of questions.
First of all, let me say that Fukushima had one anticipation in 3 Mile Island. 3 Mile Island and Fukushima got similar situation. Second point is, you cannot assume that no error are possible. Errors are possible, you recognize errors, and you have to accept that anything may have errors. So the fact that you say that this was an error here, this was an error there, and so forth and so on, is fine with me. But it doesn't tell me that error have to be prevented in absolute sense. So there will always be some error somewhere. So an errorless system, it's certainly something which is very hard to accept by human people. I'll give you a measured error. One load in a reactor is 10 to the 10 sieverts. 10 to the 10 sieverts are contained in a reactor. And 5 sieverts is a 50% killing capability. So we are talking about reductions in the radioactivity, which is 10 orders of magnitude, 15 orders of magnitude with respect to what it is. When we're talking about this, the possibility of an error coming from mistakes, from this and that, it's possible. It has to be accepted. So you have to accept life with errors. Life without error doesn't exist.
It's dangerous. We have to treat it very carefully. Question over here.
That's not my point.
But not as dangerous as other things.
Isadora Vronsky from Greenpeace. So I have a question that I asked in the previous nuclear session, which is, with commercially available technology, not thorium reactors, are we able to use nuclear power that currently make up 6% of primary energy demand to reduce or phase out over 80% of fossil fuels in the time scale given by IPCC or International Energy Agency? Do you see that as realistic? That's the first question. Second question is, what happens with the inflexible base load that nuclear make up when we get other countries that phase in a lot of fluctuating renewable energy? Can, for instance, France 58 reactors be an obstacle for Germany in the energy vendor? Are we choosing between different energy systems where the base load is putting a cap to how much renewable energy we can put into the system?
Okay, so the first question, have we commercially available build nuclear reactor to reduce fossil fuels significantly or to a large extent, if I understood the question, in time?
Well, maybe I can start a little bit of saying we are building reactors, very many reactors over the world today. What we have very close to us here in Sweden is these reactors in Finland, where they have tried to go with new designs. And one can say that every new reactor, you put more and more safety requirements, which also makes them take longer and longer time. It's a new reactor every time, you can say. But for example, in US, they have had many plans of building smaller reactors, which could be done in 5 years. In England, they have decided to build reactors now, which will be delivered by the French company, and that will also be built in time. And I think that also for the reactor places where we have, that it is, we can upgrade the reactors very much like we are in Sweden. So the question there is to replace the fossil. This is for producing the electricity. So, you know, if you think about the whole world, I can probably not say yes at all to this. If you think about Sweden, I don't think that we can replace the nuclear power we have today with something which is fossil-free. We would have to go with gas or something in Sweden. So the nuclear power that we have, we should really take care of and use.
Let me make a slightly different answer. I think to have a real crash development of nuclear, if somebody wanted to do that, in Europe anyway, the constraint in the Western world would be manpower, because there's been a pause on nuclear build-up for so long. There aren't the skills there, maybe different in Asia. I mean, that can be repaired in time, but if you wanted to start immediately, it'd be difficult. Now, the second question?
What was the second question?
Who can remember the... yes, the role of nuclear, if we have a lot of renewables, you know, how do we reconcile the... I mean...
Well, look, that's you know the answer to that.
Yeah, I do.
You bring up nuclear and you keep it steady. It's a very steady source. It's baseload. Hydro and gas can interface very well with renewables. Right. They're the ones that have the real rapid response.
But in some sense,
the question was rather whether baseload creates a problem for when we start to get really high amounts of renewable share in the electricity system. So we get a system conflict because we cannot.
Right. I think we're a long way from
like the border between France and Germany in the future to come, for instance.
Perhaps may I say
yes, if it's quick, Carl.
Yes, well, we're all quick. I pitch faster. But anyway, we have taken some time to understand this kind of question. There is no doubt that the variability of the renewable energies are a serious problem. This is both true for solar, but it's most important for wind. Wind is going like a cube of the velocity of the wind. The speed of wind is going up by a factor 2. The amount of energy transported goes up by a factor 8, and so forth and so on. So some situations you have a lot of energy, too much energy. In some other cases you have not enough energy. So paradoxically, the answer of the future to this is coming from the energy storage, which of course in case of nuclear is already guaranteed because nuclear can run all the time. Now, I don't believe that storage based on batteries, it's going to be sufficiently careful in order to solve in a conservative way all the problems we have. I have enough problem to get my little thing here, a telephone running all the time because every day it's discharging itself. If I have to have a car, my house and everything else on this, I'll be in trouble, independently of the cost. Now, I believe that the solution will come if you can transport electricity into fossils, for instance, methanol, and then go back to methanol, back to electricity again. This is possible with fuel cells. A fuel cell is sufficiently efficient, so you can take fuel cells energy from electricity to chemical, and from chemical back to electricity with a gain which is almost a factor 2, which is an acceptable number in a chain of reactions. So in my view, the answer for the future of renewable, the continuity of renewable, a high level of consumption, as is proposed, for instance, in Denmark, where one says we will only have renewable by 2050, is justified only if you can solve the problem with storage. And the only thing I know about is, which can work on storage, is fuel cells.
We have a question here from Twitter, I think. Can you read out the question?
What steps do you think the scientific community can make to help remove the fear and stigma from nuclear power?
Robert, do you want to answer that?
Well, first of all, I think we had some terrific examples here of the various kind of risks that we run. And I think this is really very basic science. You don't need an advanced degree to understand that. I think, you know, we could, at elementary school level or something, you can already educate children about the risks that are all around us. And so I think actually education is absolutely key in this. I think also it's important that we keep on emphasizing that there are risks associated. I think in Japan, one of the problems was that there was like this myth of 100% safety, which led not to the kind of improvements you were just suggesting, small things to mitigate these risks. But I would say absolutely key to this is start early and broadly by educating people with these kind of risks.
Elizabeth?
Yeah, I would also like to take up some point is the word nuclear. You know, when we go to the hospital, then NMR is now called MR. So suddenly people think that it is X-rays or something. There is no reason for us to take away the word nuclear. And why is it taken away? Because just they think that people get scared of the word nuclear? No, so we should just be clear about it, educated about it. It isn't dangerous, right?
I'll just tell you a little anecdote. The first application to make a hydrogen filling station for cars in East London, there was an objection to the application on the grounds we don't want hydrogen, that's what they make hydrogen bombs out of. I mean, that's what people think, it's a problem. I have a question here. We can take 2 more questions, I think. We're over time. We take one here. And then maybe there was one back there. Yeah.
I have a question about insurance for nuclear plants in countries with small fleets of nuclear plants.
With small what?
With small fleets, with few reactors. How is that handled?
What is the question is, how is insurance for reactors handled in countries which have a small fleet of nuclear reactors?
Oh, that's a very good question.
I know, but we don't know the answer, do we?
Well, I think I know the problem.
Even you don't know the answer, Carlo.
May I try to answer your question?
Yes, if you're brief.
At present moment, every country receives the waste, and the waste is remaining in the country where the waste was. Now, if large countries can solve their problem, for instance, US, France, Germany, UK, what is going to happen if a small country will produce waste, and then the waste has to be put somewhere with a system? There will be a major problem in solving this situation. So I believe that at least in Europe, where there are so many different countries and small countries, a European common effort in trying to decide to have one common repository for all these materials should be taken. Now, ideas of doing that came to Russia about 10 years ago when Adamov was in minister. And that time, the willing was that Siberia had enough area, space to take enough radioactivity, for instance, from Albania. I'll give you an example just like that, and brought it there, and there would be no problem. But indeed, the Duma in the Russian parliament has refused such a possibility. Similar argument applied also about Australia. Yes. Also, Australians argue that there is plenty of space in Australia where you could safely put away a significant amount of radioactivity, especially small amount for delicate small countries don't have the critical mass to be able to solve the problem by themselves. But also that one has been turned down by the decisions of the parliament. It seems to me that this is an open question. It's a big problem, as you are corrected, but there's no moment a solution, which is acceptable.
I mean, let me just comment on the Australian situation. Australia is the second biggest exporter of uranium in the world, but they won't have nuclear power themselves. It's really hypocritical.
I think your question was insurance vis-a-vis safety and things of that nature. Yeah. So the best insurance, you start with proper training, risk mitigation. Think about airlines. There's an international standard if you allow airlines to land in, let's say, the United States. There's an insistence that the pilots have a certain level of training, even if it's from a foreign airline. There's an air certification issue. Not every country can just willy-nilly throw up a plane, and so countries will say these airplanes would have to be certified if they too want to come into my airspace. They're very similar situation that has to exist with nuclear power because, you know, the contamination could actually go into an adjacent country as well as the own country. So before a small country begins to get nuclear energy and nuclear power, this has been a big debate within the United States. I was saying that before the United States actually exports some of this technology, we have to make sure those countries have the infrastructure that can train the operators and can do all those other things. Otherwise, it would be irresponsible for a Westinghouse to be selling nuclear reactors to a small country like a Jordan or Vietnam or et cetera, unless you had that. And so I think internationally, those people who might think of exporting nuclear technology, whether it be Japan or Korea or China or the US or France, have to be all together on this. A nuclear accident anywhere in the world affects the entire industry. And so you start with that. It's not after it happens who's going to pay for it. That too is important, but boy, you can mitigate the probability of it happening by a lot. And that's what we need to do.
Thank you. We're way out of time, but I did promise to take a question back there. We will take this one last question. Can you make it relatively quick, brief? They told me to finish at past. Maybe my watch is fast.
Thank you. When we look at, say, molten salt reactors, we know that they are deterministically safe and not probabilistically safe, as Professor Rubial said, but still they're not being implemented. And there are lots of these improvements for nuclear reactors, like molten salt, thorium, fusion even further away, that are not commercially being utilized. Is it because they are still in research and they are very hard to realize, and is there another way in which we can accelerate this development?
Elizabeth, would you like to take that?
I think that we really need to have the public approval of this energy system, and I think that this session really shows what we need to have. We need to have a lot of meetings talking, not only the education in the lower school. I know when we arrange a nuclear power meeting in Stockholm, it's not people coming asking questions, then it's only the people who know everything who comes and we discuss how to improve. But we don't have this general communication that we really need, and I think that's what's really needed, because there are research is there, and we even have things which are ready for testing. I mean, that even Carlo could talk about, right? So that it is there, but we don't get the public, or even we don't get the money. Like we say, there is no money for it because the money goes to the wind or something, which we don't need today. We need this.
There's another issue in the reactors you're talking about. For example, we know in a plutonium metal reactor, you just it's inherently safe. You walk away from it, and we know it doesn't melt down. There was a demo prototype reactor made in the United States that did this. But there's another issue, and that has to do with the proliferation issue, and which is why that work was stopped. And this is also the questions raised. I'm not saying whether I agree or disagree. I'm just saying the other side of this is that in fast neutron reactors, you can breed them for maximally burning down the long-lived actinides, which are a real spent fuel problem. But you're also making out of U-2, you're making plutonium, fissionable plutonium out of U-238, which is capturing the energy content. But you can produce more fissile material this way, and so that's the other side of this that has been in play for the last half century.
So we're almost 10 minutes over time. There's another session beginning shortly, so I'm afraid we have to end it there. And please thank the panel again and the audience.